I'm a bit late to the party, but 5 years ago, scientists from all around the world celebrated the 100th anniversary of a theory that laid the foundation of understanding of various astronomical phenomena and devised a completely new description of gravity. This theory was published by Albert Einstein in 1916 and named the theory of general relativity.
Einstein's happiest thought was imagining a man falling off a roof. It made him realize that the man would not be able to differentiate free falling from floating in space. In either case, he would feel weightless. And since forces act continuously, that meant Newton's law of gravitation was not accurate. Gravity was not a force. While the water bottle is stationary, the water inside is experiencing the so-called force of gravity, which pulls it out of the hose. But as soon as the bottle goes into freefall, the water no longer feels that pull, thus no longer sprays out. Thus, gravity is not a force.
Einstein realized that objects in the universe exist in three-dimensional space and one-dimensional time, and since space and time are interchangeable terms, that means time can be used to describe space, which is distance, and space can be used to describe time, he was able to combine them into a four-dimensional manifold called space-time. Remember how we couldn't differentiate free-falling from floating in space? Well, we also wouldn't be able to differentiate standing on Earth from accelerating in deep space with a 9.81 meter per second acceleration. And according to Einstein's theory of special relativity, acceleration warps space-time, and as an effect causes time dilation and length contraction. And since gravity and acceleration are indistinguishable, gravity must warp space-time too. And that is true. Experiments show that gravitational fields do slow time down. This is the fabric of space-time. Masses curve space-time. These curves are gravity. The greater the mass, the greater the curvature, the greater the gravitational pull. But in this model, space-time is just a flat two-dimensional surface. But masses, they curve space-time in 4 dimensions. We can imagine this in another way. The mass being a drain in the water body of space-time. Now, this is how a 3-dimensional drain would look like. An extra dimension would mean that the issue of water collection at the center sorts itself out.
We can rely on the theory of general relativity to better understand the universe surrounding us.